Alright, here's our project. We didn't hook up the power source to the resistor, but the functionality is still working the same. So if you look at our circuit, you've got ambient right here. You get the transistor that would normally go to turn off and on to the current to the resistor, which is right here over top next to another transistor, which is controlling our transistor for the heater. And here's our view in lab view, which is currently running. You got the frequency, which right now we can bump it up to about 1000. You have V hot, which is obviously coming off of our heater transistor, and V ambient, which is the ambient temperature. Our temp hot and our temp ambient, the calculations are incorrect right now, but we're still able to show a difference. So right now if you watch, it's showing because the voltage for hot and voltage for ambient are approximately the same, then we wouldn't run any current through it because they're reaching the values that we want. But right now if I cover up the ambient and heat it up, then it's going to turn on that duty cycle so that it'll kick V hot up so that it would match it. So right now it's at a 0.75 duty cycle. If I uncover it, so I'm just covering and uncovering with my finger to heat up the transistor. So right now I'm going to go cover up the heater transistor, which should take our duty cycle to 0 because I'm simulating heating it up. Now it's flickering back and forth, and it's almost to 0. And now it's at 0, so the heater would be off. And then I'm once again going to uncover it, cover up the ambient transistor, and you see that's going to turn the heater on because it's going to try to match it. Uncover, going to cover up the heater transistor again, simulate heating it up. And just give it a sec. Okay, it's starting to flicker because it'll be turning off and on the heater, and it's down to 0. If we were to run this in, so this is the closed loop. If we were to run it in open loop, you'd just run off experimental values and just pump heat to the V hot, whatever you find out. So let's say the duty cycle needs to be like 50 or 40 or something. You would just pump that constant, and you wouldn't monitor any of the V ambient for any differentials. To show the differential for our actual circuit in lab view, you got the heater coming in, V hot, just so we can view it. The ambient one, ambient voltage. You had some conversions that we realized are incorrect, so we're getting incorrect temperatures, but at least they're both consistent, so we're still getting some different temperature. Comes in, goes into a differential, and what it's doing is if those are less than 0, so that means that the temperature of the hot, let's say it was like 42 and ambient was 40, then obviously you don't want to turn it on, so it wouldn't be less than 0, so the false case would run, which is just going to output, let me go into it, it would output just a 0 to the duty cycle. But if it's true, so let's say you have 40 as your heater and 42 as your ambient, that's going to give you a -2, which is obviously less than 0. It's going to pump a duty cycle into the PWM generator, and it's going to pump that out and control that transistor, let current flow. Okay, and that's it.